Okay, so we're hoping that exam 1 will be 2 weeks from today, October 20th. That's my goal. We'll see how things go as we get closer. But how it'll work on exam day 2 is that we'll do, the first half of the class will be review. We'll spend maybe an hour or so reviewing and then let you guys take a break. And then you'll have probably an hour and 15 minutes to take the exam, somewhere in that range. It's a short exam. It's a 50-minute exam. It's built for 50 minutes, 50. So not too bad. This practice exam, do you guys want it now or do you want it closer to the exam? Who likes to prepare 2 weeks in advance and who would not like to have it before they have all the material down?
Closer to the test.
Closer to the test?
Yeah, because we probably haven't seen a lot of the stuff.
Yeah, there's still all of Unit 3 we haven't seen yet, and that's on the exam as well. So I'll hand it guys out to you next week. Just remind me. It's going to be right in here. Okay, good. So today what we're doing is we're going to finish up the horizontal translation, and then we're going to get into intro to inverses. Then I want to go through your homework graphs of inverses and one-to-one functions. We may get into the intro to linear functions. We'll see. All right. So today you have that due in class is the reflections homework, reflections graphically. So I will want that by the end of class. Do you guys want to turn it in a little later? You can turn it in now if you like. And if you want, you can turn it in. You just feel free to drop that up here later in the class as well. Friday, don't forget you have the due in class is the paperwork, the vertical translation. So that's the one we did last Friday, right? Where you translate things up and down vertically, and then also you'll have due Unit 2 on translation of functions. So that's coming up in a couple days. We've done vertical translation and we've touched on horizontal translation, but there's still a fair amount of horizontal translation that we should probably discuss more, because half those problems are going to be on horizontal translation, and you're going to want, it's due in 2 days, right? So make sure you work on it between now and Friday. You haven't had a Math Lab open, a My Open Math homework due in a while, so you should have plenty of time hopefully to get in there tonight and tomorrow and really work on it. So if you have any questions on Friday, you can bring them in and we can discuss it. And then on Monday, you'll have a next, so My Open Maths, you haven't had any due for quite a while, since last Friday. But they're going to kind of come fast and furious, right? So then we'll have that one. Monday, you'll have another one, but no paper stuff. And then next Wednesday, we'll have another one on linear equation review. So you've got a few coming in here pretty quickly. So it's going to kind of ebb and flow like that a little bit. I'll try to control it a little bit by trying to get your paperwork ones, not necessarily, during the off times of that when I can. Okay, so let's go ahead and I'll pick up the reflections homework. Great. Thank you. Thank you. Thank you. And thank you. All right. Oh, and then I also have your homeworks graded to hand back. So I'll remind you to hand this back a little later on. All right, good. So let's hop into horizontal translation. So go ahead and grab that handout. Looks like this, correct? Right, so we did all the easy stuff. And then we got into, so if you remember, horizontal translation is when you shift along the horizon. So if you think about looking at the horizon, watch the sunset over the horizon's like this. So horizontal translation is when you move side to side like this, along the horizon. So it's, maybe think of horizon being anywhere you want, but basically it's along this way. Vertical translation is when you move up and down. Right now we're focusing on horizontal. So if you're talking about just moving points, it's exactly the same thing. If I want to shift, I'm here and I want to shift 2 to the right, then I would just it means that my x, my point would increase by 2. If I wanted to shift 3 to the left, then my x value on the point would decrease by 3. So let me show you what we're talking about, just as a quick reminder. So for example, this point here is, no, we'll do a better one. We'll start at the top. Okay. Make sure we're clear. I didn't take a picture of this too. Hold on, just a quick minute. Actually, we'll do that. Okay, so if you guys remember, for example, this point is 1, 2, right? I walk 1 to the right and then I go up 2. So this is 1, 2. If I were to shift it 2 to the, shift 2 right, that does exactly what you expect it to do. Okay, my x would become 2 more. So 3, 2. If I were to shift it, say 3 to the left, shift 3 left, then it would go, well, 1 minus 3, negative 2, 2. Right, so the graph part works exactly like you expect it to work. But the thing about it is the symbolic part is tricky because normally with the y, if you guys remember, y equals, say, 3x plus 1. If I want to shift, say, 3 up, then I would just add 3. Y equals 3x plus 1 plus 3. No problem, right? Because this 3 is on the opposite side of y. So if I want the y to go up, I just do that. No problem. But with the x, it's a little bit tougher. So here, I want to do shift y equals 3x plus 1 right 3. That's harder because, okay, let me give you an example. When x is 0, here, y is 1. If I go up 3, I need y to be 4. So here when x is 0, y is 4. Everybody kind of on board with that part? The problem is I need, here when x is 0 and y is 1, I want, if I'm going to go right 3, I want x to be 3. And y to stay at 1. So I'm kind of following me? So I need the y to still be 1, which means that I need this to still be 0. So, oh wait, I won't work when x is 0. Oh yeah, well. Okay, so I need this to still be 0. So when x is 3, I need this to be 0. So the way to do that, it's a little bit tricky. I'm going to throw you guys off a little bit. Is right where x is, I'm going to replace x with x. I need this to be 0, so I need this part to be 0. How to make it 0 if x is 3? This has to be minus 3. So if I want to go right, I need to do the opposite, because doing the opposite makes x a little bit larger. that sort of make sense? It's hard to explain this one, so it's still a tough one. So you can just understand the rule. I really hate people just accepting a rule, but that kind of might be the easiest way to do it in this case. So here, I'm going to do it right inside where x is, and I'm going to replace x with x minus 3. Because then x can be 3 bigger and still be the same, and still have this be the same value. Right, so whatever this used to be, whatever value this used to be, it would still be the same if I made x 3 bigger, if I do x minus 3 here. So that's kind of that's all the reasoning. So this is how the shifts work. For vertical translation, with the y, you just add it to the end, this minus 3, plus 3. But with horizontal translation, where the x is, you replace it with x minus whatever you want to shift. So if you want to go to the right, you do x minus whatever you want to do to the right. If you want to go left, I do x plus whatever goes to the left. So let's have you guys do a practice one. I have y equals 2x minus 4. I want you guys to all shift it right 1. So right, give me the new. For now, you don't have to simplify it, just write in what it should be.
I totally get what we're supposed to do,
Mhm.
but I don't understand why it works, so maybe if you could just do this on the
I've
graph.
explained it twice.
No,
So
I'm just saying on the graph so we can see actually how it works. I understand why how it works, but I don't understand why it works on the graph.
okay, we'll try that in a minute. Okay, so shifting it right 1. Again, you're going to rewrite this, only instead of x, you're going to put a giant parentheses. And inside there, you're going to take the x and you're going to do what with it? X minus 1. Right? That's everyone's got that? Because right means minus. Left would be the plus. Because you subtract off, however much your right move is. And then ideally you clean it up. So ideally you do, 2 times x, 2 times 1, so I get y equals 2x minus 2 minus 4, and then obviously combine your like terms. So which are my like terms? -2 and -4. So I get, 2x minus 6. Combine like terms. I owe $2, I owe $4, I'll do that, I owe $6. So graphically, what's happening is, say we're at x is 2, we're at 0. Let's pick when x is, so x is 2, we're right here at 0. And I want to say, so I'll put in some lines here so you guys can see where we're at. And I want to shift it right 1, so it means I want to go here. What would that mean? So that means that now my x, I want to get the same y out of this. You can think of it that way maybe, Eric?
Mm-hmm.
And so I need to get the same y out of it, but I still need my height to be 1 even though x is 1 larger. So x is 1 bigger, but I still need the height, I still need this part here to show up as 2. even though my x has gotten bigger. So since my x has gotten bigger, I need to subtract 1 off my x. So here, my x was, what I had was 2 here, right? So I need this to be 2. Like, how do I make this 2 to make x? I need to make x, if x is 3, I need to subtract off 1 to get back down to 2. I kind of think of it that way. I need my y to still think it's 3. I think it's harder for me to explain it that way. I don't know why graphically it's not really a good way of explaining it.
Oh, really? I don't know, yeah.
I mean, I just think that, I think I'm more confused now than I was 2 minutes ago, so I would not.
Yeah, I mean, I understand the steps to get it and everything, I just didn't know why it worked, you know?
Well, I think the best way is what I talked about last class, which was
Yeah.
when we, remember when we shift the y, 3x plus 1, if we want to shift the y up 1, we just, or up 2, we just add 2 to the end, because you're adding the opposite side.
Yeah.
But if I want to shift x, then I first have to solve for x first, and then add, whatever I want to the other side, and then resolve back for y. So remember what I did was I said, let's solve for x, so I do y minus 1, right, to get rid of the 1, and then I divide by 3 to get rid of the 3. And then you can add 4 to both sides, or I want to shift 3 right. Then you would add 3 to both sides, right? Y minus 1 over 3 plus 3 equals x. But now when you solve back for y, this plus 3 becomes minus 3. So that x becomes x minus 3 because you're adding it to the other side. So then I end up with y minus 1 over 3 equals x minus 3, even though you're shifting right. And then we're going to do stuff to it. I'm going to multiply it by 3. And then I'm going to, sorry, see if I get through that part. And then I'm going to do, I should probably just take that part off. And then I'm going to add 1 to both sides. So then, if you look at the first, 3x plus 1 becomes 3, in parentheses, x minus 3 plus 1. Yeah? Totally. And really, if you think about it, with the y's, if I was doing, think about shifting, if I shift the y, right, I have y equals 3x plus 1. If it was on the same side as y, and I want to shift it plus 2, right, up 2. If it's on the same side of y, I do the plus 2 here. If I was putting on the same side as y, this would be y minus 2 equals 3x plus 1. Do you guys sort of see what I'm saying? It's easy because I'm doing it on the opposite side of y. So it's just plus 2 or whatever I want. But if I were to move that over to the other side where y is, it becomes y minus 2. So that's the thing. Because it's on the same side as x, then right is minus, left is plus.
Oh, yeah.
If it's on the same side as y, then up would be minus 2 and down would be plus 2. It's on the same side.
Yeah.
So that's the deal. Because it's on the same side as x. If it's on the opposite side, it'd be normal. Plus would be right and minus would be left. But because it's right, it's on the same side as x, then it's the opposite. So the general rule is y equals, 3x minus 4. If I want to shift left, then you add inside. You're going to shift right, you're going to subtract inside. But remember, the left-right, you're doing it right inside where x is. So right where X is, you're going to do parentheses X minus whatever. Is everybody kind of okay with that part? So it's right inside where X is. Right inside where X is, you're going to do the X, if I did this, X plus 2, that'd be shifting it what? Everybody think about which way am I shifting and how much am I shifting?
Left 2.
Left 2. Everybody all right with that part? Let's change it. Now everybody write down on a piece of paper how much I'm shifting and what direction I'm shifting. Just write on your, yeah, anywhere you want. Okay, check the answers with your neighbors. Turn around,
Right plus 1.
Natalia, can you check with David? Check your answers. What'd you guys get? So minus is going to be left 1. Good? So this is left 1. Okay, let's try this one. Oh no, sorry, right 1.
Right 1, yeah.
Minus is right 1. My bad. Thank you for double checking me. How about this? Check with the neighbors. Left 4, good? Okay, great. I can show you. Let's try Desmos. To do Desmos, I do this. You can see I'll do y equals 3 parentheses x minus 2. Let's do 3x. 3x minus 4. Oh, equals 3x minus 4. Okay. 3x plus 2 minus 4. So you can see it shifted right 2. So everyone kind of see that? Kind of look at this point here, it's a good spot. Right 2. It's a little bit harder to see. It's a little bit harder. Let's do these guys. These guys are a little bit easier to spot. So I make them squared. So you can totally see how it went right. Or sorry, left 2. Everybody looking at that part? If I did, instead I did minus 4, you can see it totally instead goes right 4. So it's a little bit easier, I think, to spot. But what if I do this, and then I do plus 1? What's going to happen? It's going to go right 4 and up 1.
Yeah.
I should probably change the settings so that each one is step 1, step 1. That's easier. Okay. So what would I do? What would I type in here if I wanted to go